Good morning. So we're going to be going over math challenge number 11 and then looking at math challenge number 12. If you're a student in my classroom who's watching these videos and doing them, please make sure that you have gotten onto your Gmail and that you have signed into our Google Classroom. I will be starting next week posting the math challenges on there too, so that all of our answers for my students will be in one place for these. That'll hopefully make it easier than sending them all to me individually. So then we can all be in one place. All right, so math challenge number 11. Two of them are ones that I couldn't really put an answer to on the answer key because they were things that you were doing separately at home. So choose two people in your home, multiply their ages together to see what you get. And then we said if you had more than two people at home, then try out some different combinations, some different numbers, and multiply all the different ages together. Okay, number 2, adding mixed numbers. So when I added together 2 plus 3, I got 5. 5 plus 7 gave me 12 eighths, and this was the one that we did together as the example on the last video. So I walked you through this one already to show you how we would go ahead and do that. So the second two are the ones that you did individually. So 4 plus 7, because I do my whole numbers first, 4 plus 7 is 11. 3/5 plus 4/5 is going to give me 7/5. This is an improper fraction because the numerator, 7, is bigger than the denominator, 5. So that means if a whole has 5 pieces and I have 7, then I have more than a whole. Okay, so if I had a pizza, it's cut into 5 pieces and I have 7, well, that means that I have more than a whole pizza. So I take out a whole, which is 5 over 5, that's a whole pizza. And then I take out whatever's left. I have 7 as my numerator. So far I only had 5, so how many more does it take me to get to 7? 2 more. 5/5 and 2/5. Okay, so I don't have 11 whole pizzas, because here's another whole. I have 12 whole pizzas, and my fraction left over is 2/5. So I have 12 and 2/5. This one down here, when I add up my whole numbers, I have 6, 7, 8, 9, 10, 11. I have 11. Then I add up my numerators. 9 plus 7 is 16, and 5 more gives me 21. So I have 11 and 21 tenths. So now I need to take out wholes. Well, what's a whole here? 10, because the denominator is 10. So this problem, the whole is 10. So I take out 10 out of 10. Then I can actually take out another 10 out of 10. So 10 plus 10 gives me 20. I'm trying to get to 21. So the last piece would be 1/10. So I don't have 11 wholes. I have 12, 13. 13 wholes and 1/10. Okay, and again, number bonds are new to a lot of our parents and things, but in this instance, it's a really good model to be able to see how do I get a mixed number out of an improper fraction. Okay, you can divide too, and we will look at that later, but this is a really easy visual model to say, pull out a whole, pull out a whole. It's using addition rather than using division, and it's not that tricky to do. Okay, and then lastly, you were supposed to come up with 3 word problems of your own that have 2 steps. So anything you wanted, as long as they needed to have 2 steps. And then solve them so that you have an answer key and see if there was anybody that you could get to solve them. Maybe a sibling, maybe a parent. See if there was anybody else who could try out your word problem and see if they got the same answers that you got. Okay? Math challenge number 12. Oh, this is fun. Such cooperative children. Mackenzie was cooperative and kind for 36,754 minutes. Good job, Mackenzie. Grace was cooperative. Oh, I'm sorry. Andrea was cooperative for 39,386 minutes. Grace was cooperative for half of the total minutes of Mackenzie and Andrea combined. How many minutes was Grace cooperative? Okay, so 2 steps. You need to find the total first before you can figure out what half of it is for Grace. Okay, more adding mixed numbers. 6 and 5/7 plus 4 and 6/7 plus 3 and 6/7. And the second one, 9 and 3/4 plus 8 and 3/4 plus 6 and 3/4. Okay, then we have some rounding to the thousands. I'll hold it here so you can see those numbers. You're gonna round each of those to the thousands place. Underline the thousand, visit the neighbor. If that neighbor is 5 or above, you're gonna give that underlined guy a shove. If not, he's gonna stay the same. And all the digits to the right turn into zeros. Okay, and then 2 multiplication problems that are 2-digit by 2-digit. All right, give them a try.